let's evaluate some student loan options. So what are options? Well, there's a few different kinds. So first of all, there are federal versus private. So these are two different types. And then within that, we also have fixed rate versus variable rate. Now, the thing with fixed rate is that you will have the same percentage the entire time. So if you get the loan and it's 2%, it's going to be 2% the entire life of the loan. Whereas with a variable rate, it might be 2% for the first 2 years, and then it might be 5% for years 3 through 6, and then it could be 10% for years 6 through 10. You just never know. So variable rate means the percent will and may change. Okay, so those are kind of different types. Now let's kind of see what this means. In a federal student loan, this is a fixed rate set by the U.S. government. The paybacks start after graduation, and interest doesn't start until after graduation. So with the federal student loan, they pay the interest while you are still in school, and then you take care of it after. It does not require a credit check or a cosigner. You must have a Social Security number, so you must be a resident citizen of the U.S. for that, or have a Social Security number. And the big thing, maybe a problem, is that it is a limited amount. So you might only get $5,000 of a federal student loan, and your tuition might be $12,000. So you're going to have to find something to fill in the gap. That's the issue with federal student loans, that you don't get to request how much. They tell you how much you deserve based off of your financial need. Now, for a private student loans, your payback starts while you're still in school, and the interest starts right away. So you start accumulating interest as soon as you start borrowing money, and you have to start making monthly payments as soon as you start borrowing money. They tend to have variable interest rates. A lot of times those interest rates will depend on your credit history. So the lower credit score, the higher the interest rate, all of that kind of thing. With all of that, they are usually more expensive than a federal loan. But the best part is that you can use these to bridge the gap. Because again, with a federal loan, if you only get a few thousand but you need more, then you can get a private loan to kind of cover that gap. Okay. So the formula that we're going to use for this is D equals P times the quantity R over N, all divided by 1 minus the quantity 1 plus R over N raised to the negative NT power. Now, D is our monthly payment. So this is the formula we use to find the monthly payment for our loan. P is the original amount of the loan, the principal amount of the loan. R is our annual interest rate. We have to divide that by N, which in our case is going to be 12 because we make monthly payments. And then T is the number of years for our loan. So let's go ahead and get into this example. Colin is presented with 2 loan options for an $8,000 student loan to cover fall semester. Option A is a 10-year fixed rate loan at 5% compounded monthly. Option B is a 15-year fixed rate loan at 4.5% compounded monthly. What is the monthly payment of each loan, and what is the total interest paid under each loan? Ultimately, if we answer those 2 questions, we'll be able to see which is the better loan option. So first, let's focus on option A. So we know in option A, we're trying to find D. So the principal amount is $8,000. My interest rate is 5%, so as a decimal, it's 0.05, and our time is 10 years. So with that, we can plug this in to our formula. D equals 8,000 times 0.05 over 12, all over 1 minus quantity 1 plus 0.05 divided by 12, raised to the negative 12 times 10 power. Now, if you're going to put this into your calculator all at one time, that's fine. Just make sure that you put extra parentheses around the numerator and the denominator. And in the denominator, put extra parentheses around the exponent. Okay, that's super important. If you prefer to do more numerator, denominator separately, that's great too. You will end up with approximately 33.33333 repeating in the numerator and 0.3928. I think it's a 38. My handwriting is a little bad. These repeat. Now, we want to avoid rounding as much as possible. But if you need to, you just carry it out as many places as you can and round appropriately. Okay, so if we divide this, we then end up with a monthly payment of $84.85. So again, that is the monthly payment for loan A. Great. Let's go to B. Okay, so option B. We still have the same 8,000. Our rate is 4.5%, and our time is 15 years. So when I plug that in, my monthly payment, I have 8,000 times 0.045 divided by 12, all over 1 minus 1 plus 0.045 divided by 12, raised to the negative 12 times 15 power. Again, if you want to put this all in, parentheses around everything, and extra parentheses around your exponent. If you play numerator, you get even 30, and in the denominator, 0.49820037, on and on and on and on. When I divide, I will get a monthly payment of $61.20 for option B. Okay, so for option A, our monthly payment was $84.85. Oops, that's really sloppy. Let's rewrite that. 85. And for option B, our monthly payment is $61.20. Now, this should make sense that option B has a lower monthly payment because it's 15 years, right? Let's just remember that. This is for 15 years. This is for 10 years. So if you need a lower payment by $23 or so, option B is great. But remember, the second part of this question was, what is the total interest to be paid? Okay, so now let's think through what this means. In option A, I am paying $84.85 per month. So if I multiply this by 12, that will tell me how much I'm paying back over the course of 1 year. And I'm doing this for 10 years. So multiplying by 12 gives me to 1 year. Multiplying by 10 gives me to 10 years. So my total payback, how much I'm paying over the life of this loan, is $10,182. If I borrowed $8,000, so let's subtract the $8,000 we borrowed, that means the interest is $2,182 because the difference between what I paid back and what I borrowed is interest. Okay, so that's loan A. Now for loan B, I'm paying $61.20. If I multiply that by 12 to get me a full year, that's a year. Then I multiply by 15 to give me 15 years, because remember, loan B is a 15-year loan. So this gives me a total payback of $11,016. Again, I only borrowed $8,000. So that means the interest for loan B is $3,016. So I'm paying almost $900 more in interest to have this loan stretched out for 5 more years. So if, in this case, if you can afford the $84.85 a month for 10 years, you will save roughly $900 over the course of the loan because of interest. So even though loan B, if you recall, has a lower interest rate by 0.5%. So it has a lower interest rate, but because it's 5 years longer, it's going to cost you more money in interest over the long run. When possible, go for the lower years. Do the math, because you never know what the interest is going to do to you over time.